Good morning, folks. Hopefully you had a relaxing Easter break. And so we're going to continue on with our plan. So this week we have lesson 9, which is two variable summary. We've got a review and we've got to practice two variable analysis. That will set the tone for next week, where you have an assignment, a two variable assignment that'll be given to you. You have to get it done. If you get it done by, so I'll post it on Saturday. If you get it done by Sunday afternoon or Sunday evening, I'll try to mark it as quick as possible and get it onto your report card. If you want to take your time, that's fine too. You hand it in later and it won't get onto your report card as a mark. So that's the plan. You'll get your updated marks this week with your last assignment marked. And so next week there'll be the two variable assignment and a test, and that'll conclude the first half of the semester. After that, we have our major project, and then we have the more difficult math. And so I haven't decided if I'm going to do both of them simultaneously, so you'll have some time to do your major project each week, but I'll slowly introduce the new lessons. I think that's how I'm going to do it. And so you get new concepts each week, but it'll be a slow pace while you're also working on your major project. And so let's get the two variable summary lesson done. So I'm just going to do some commentary on that, and then you'll have the rest of the week to work on the review and the two variable summary. And I'll also answer any questions you have under discussion. If you post a question in discussion, if I have to make a video, I don't mind doing that. Just make sure you're trying the homework and your review as well. Solutions for review should be posted as well. All right, thanks. Okay, so we have two variable summary, day 9, the last lesson of the unit. And first thing we got to do is part 1, identify the variables for analysis. So in your major project, you're going to be doing the same thing. You're going to do 2 single variable analyses and then a 2 variable analysis. So really the very first step, part 1 for your major project, you will have already introduced variable 1 and done a single variable analysis. And then you'll have done variable 2 and done a single variable analysis. Really important that you make sure you know the dependent and independent variables, and you can tell the difference between the two, because you really don't want to mix those two up and kind of have your two variable analysis flipped. That would be a significant problem. Scatter plot and correlation. Generate a scatter plot and state the correlation if any exists. So you, on your major project and in your assignment, will be using Excel. And so you're generating a scatter plot. You've already practiced that in the past. Shouldn't be a problem. Correlation, if any exists, that's a function you write into your Excel. It's equals correl, and then you highlight the data, comma, highlight the data for the two variables. Again, that's in your instructions. So correlation, it's a thing you write into Excel, equals correl, bracket, highlight the data, comma, highlight the data, comma, or bracket. And that'll get you the correlation coefficient. And the correlation coefficient tells you the linear strength call for your two variables. So if it's a strong, moderate, or weak correlation, positive or negative. Next, a regression analysis. So now you're going to go and check all the other types. So the curves. You're going to redo the scatter plot and check it for each type of curve that we've been studying. And in your major project, you don't need to present all the curves that are not strong. The strongest R-squared value is the one you're going to use, and whatever one that is the only one you need to show. You don't need to show that you checked power and exponential, but it was quadratic. I just need to see quadratic in your major project. When you do your assignment, it's going to ask you to show all of them, just so you know how to do it. But again, in your major project, you don't need to show all of them, just show your strongest. State any outliers and repeat if the outliers exist. So you're going to have to do it with and without outliers. And ideally, in your major project, you're going to remove an outlier and then tell me why it's like that. Why is it an outlier? what's going on there that messes it up compared to all the rest that it should be removed. You got to justify it somehow. Summarize your results, identify causal relationships or what type of relationship there is, and make predictions if appropriate. So if you have a reasonably strong model with a reasonably strong R-squared value, you would make a prediction. So you're going to sub in a value into your equation and get an output. So that's where you're practicing subbing in X and getting a Y. And if you wanted to, you could sub in a Y and solve for an X. That's fine too. It's actually good. But if you're having difficulty with the exponential or the quadratic models, you can ask for my help or do the easier one and sub in X, solve for Y. That one doesn't require you to factor the quadratic or use the quadratic formula, and it doesn't require you to use log to solve for X. For women, pregnancy lasts for about 9 months. In other species of animals, the length of time from conception to birth varies. Is there any evidence that gestation period is related to lifespan? So life expectancy versus gestation period. Is there a relationship? First thing, you got to identify the variables. So 2 variables we're looking at. They're quantitative. By the way, your major project has to be quantitative variables. You got life expectancy and you got gestation period. Yours isn't going to be 18 animals, it's 50 data points for your major project. All right, generate a scatter plot, state the correlation if any exists. So using Excel, you generate your scatter plot, and using Corel, you use the Corel function and you get a correlation coefficient R value of 0.54, which is a moderate positive linear relationship. Now correlation, that word can only be used for linear. Don't use that word if it ends up being a curve, that's best. So there's your second spot, scatter plot and correlation. So you show your linear. So as life expectancy of an animal increases, so does gestation period. Fine. All right. Now the next step. You can check for the other models. If it's clearly linear, then that's fine. But if you think there might be a curve, then check the other 4, the regression analysis. Line of best fit. So it's linear. They don't need to check the curves. The line was the best one. And what we have here is an equation. You can sub in for X and solve for Y with that equation, or you can sub in for Y and solve for X in that equation. And you've got R-squared value of 2956, which says is about 30% of the variation in the Y. So the gestation period, the Y value, gestation period, 30% of that change in gestation is a result of the life expectancy changing. The rest of it, the 70%, has to be other factors that are going on. Now, if you see an outlier, something that looks unusual, then you need to remove it. We've got an outlier. It doesn't really fit the data. Everything's going up to the right. It's way to the right, and it's not going up. Something's weird. So let's try to figure out, first of all, what is that animal? That animal ends up being humans. So we remove humans, and you can make your argument if you research why a human might be reasonable to be removed from this. You remove the human and you redo the study. Without the outlier, the line of best fit through the data has an equation. Okay, so now we have a new equation and we have a new R-squared value. Coefficient determination R-squared is 72% of the variation in gestation is accounted for by life expectancy. So huge jump in the value when we remove the outlier. And now your model, if you sub in, it's going to be way more accurate in predicting, because the higher R-squared value, the more the model is kind of showing you what's going on, and the better the predictions will be. The R value is now 0.85, which is a strong positive linear correlation. So now you've moved from moderate to strong because of that removal of the outlier. Basically, things are better with the outlier gone. Conclusion: summarize your results and identify causal relationship. Make a prediction if appropriate. So, your step 4. Removing the outlier from the data, we see there's a strong positive linear correlation between life expectancy and gestation period. Appears to be cause and effect. Lifespan of the animal affects the gestation period for that animal. And you move on to sub in X, solve for Y. So lifespan of 20 years, sub in for X, solve for Y. You get 270 days by this model. So you just sub in, as shown there. You could also solve for Y if you wanted to, and solve for X. Now, the sub in for 20 years and solve, that actually is an animal, the squirrel monkey. You predicted 270, the actual number is 150 to 170. So your model isn't perfect, obviously, but you could make those predictions and then check from, your data to see if any animal or whatever you're looking at and you're studying, whether anybody fits your prediction, and see how your model does compared to the prediction. So that's what we're doing here. We're just making a prediction based on model and then comparing it to any given animal that lives 20 years and seeing what their gestation period is to see if our model's good. It's obviously trending higher than that squirrel monkey actually is, but we got a rough idea.